Hi everyone. In this video I'm going to talk about open calls as a form of mass collaboration. And so compared to human computation, which I discussed in the previous video, open calls involve projects where researchers pose a problem or they have a kind of a clear research question with an easy to check solution, and ultimately they ask for the submission of different competing solutions from lots of different people, but it's not about aggregating people's responses like in the human computation part that we talked about in the previous video, but it's actually about finding the best and picking the best solution. So, for example, the Netflix prize was this open call by Netflix to basically find the best algorithm to predict movie preferences, right? Depending on previous ratings of other movies, right? And so this is a task where one solution is ultimately the best solution, and the researcher just picks or in that case, Netflix just picks the solution that is most accurate, and it's easy to check whether it's most accurate, right? Because you have ultimately, it's easy to validate for if you have a holdout test set where you actually know people's ratings of the movies, for example. It's easy. There's an easy metric to test the quality of a given submission, right? Folded, where it's about protein folding, is another example where there's a clear metric of kind of the energy state in the protein that allows you to compare whether this is a likely to be the folding structure of that amino acid or of that protein. It's not easy. It's a hard problem because there's so many different there's so many different kind of alternatives of how to fold a protein, but ultimately, once you have a given constellation, it's straightforward to quantify and compare whether that configuration is better or worse than another configuration, right? So a hard problem with a lot of potential solutions, but it's easy to compare the solutions, and that's the key to these open call problems, right? Another example is the peer-to-patent kind of project or example in patent law, where basically patent reviewers have to decide whether a new kind of patent application is valid or whether it actually kind of involves already previously, or the way it's described in the patent laws, whether prior art exists, right? Whether a given technology already kind of existed before, right? And so this is a very difficult task that involves a lot of different, also ethical considerations, in the sense, or not ethical considerations, but competing interests of different actors that are involved, right? So on the one hand, there are the patent reviewers who, of course, have to have a large caseload of patents that they need to review, not necessarily have all the subject expertise about potentially relevant previous patents or prior art, but at the same time, people there's a need to keep patent applications secret, so that it's not straightforward to publish patent applications, because if it's a new development, that of course is something that the company that is working on that specific patent wants to keep secret, right? So peer-to-patent is a really cool example where this task of finding relevant prior art that might potentially make it or ultimately lead to the patent application being rejected, where finding that prior art is ultimately outsourced or crowdsourced, so to speak, to external reviewers who kind of research and find prior art and can submit that as a potentially relevant prior art to the patent reviewers themselves, right? And so this is a project. This is an example of kind of crowdsourcing or the research and finding these potentially relevant prior prior patents and prior art that might be relevant to the pending patent application. And of course, the advantage is that it expedites the process greatly, and ultimately makes it more likely that also relevant patents are being found. Okay. One important thing to keep in mind, and I kind of touched upon this with open calls, usually involving problems that are easy to check, or it's easy to check or compare, kind of the quality or the quality of one submission versus another submission, is because these open calls often involve ultimately prediction problems, right? So the Netflix prize is one a great example of this, where the goal ultimately is to predict future ratings of movies based on past ratings of previous movies, right? In order to kind of predict consumer behaviors, right? And so whenever you have a prediction problem, of course, it's easy to check whether your prediction or whether your submission is good, because ultimately you can compare, if you have a held out set, you can compare your prediction to the actual outcome in the end, right? So in the industry, or when we talk about the protein folding projects or research related to protein folding, there are these are often tasks that are directly related to prediction. But the problem in the social sciences is that social scientists oftentimes don't care so much about prediction and kind of predictive validity, but rather care about kind of testing causal hypotheses, right? So if we kind of have a basic regression model or basic linear model that produces two different things. One is of course our kind of effect of our independent variable beta hat, and y hat as kind of the predicted value in our outcome variable. In social sciences, we're oftentimes not so much interested in y hat and getting as accurate of a prediction in our outcome variable, but rather interested in the causal, for example, identifying the causal effect of a certain treatment, right? So social sciences generally ignore y hat, or the prediction aspect itself is not so important in a lot of social science projects, whereas in data science, if we look at the Netflix prize example again, this is an example where it's all about the prediction and the quality of that prediction, and not necessarily about understanding the underlying causal mechanism of why certain movie ratings lead to a higher rating of another movie. Ultimately, that is doesn't really matter as long as the prediction is as accurate as possible, right? So since data science and a lot of kind of these industry problems are focused on prediction, they kind of lend themselves more to these open call mass collaborations. And as you can see from the examples that I discussed, it's harder compared to the mass collaboration. So the human computation task, it's harder to find examples of open calls in the social sciences, because the questions that social scientists asked often less about prediction and more about underlying effects, focusing on kind of the underlying mechanism, underlying causal questions, right? But the key is that these are not necessarily mutually exclusive, right? And so one thing to kind of keep in mind is that this kind of dichotomy between explaining explanation and prediction um, is not so clear, and at this or in other words, the we as social scientists, we can kind of reframe how we think a lot about a lot of kind of causal questions, and take into account, or we shouldn't only focus on kind of answering causal questions, but also take into account prediction and predictive accuracy as a goal in the scientific process, right? So I will upload 2 papers that kind of dive into more into this distinction between prediction and explanation, or focusing on causal effects versus kind of prediction in observational settings. And so the underlying take home here essentially is that a lot of social science questions can be reframed or can be informative if they include kind of predictive problems, or focus more on predictive problems rather than only focusing on causal questions, and can include observational aspects. And once we reframe the questions to kind of include prediction, then there can also be opportunities to kind of foster mass collaboration using something along the lines of the open calls that we've seen in the industry, but also similar to when we look at biochemistry and protein folding tasks in the natural sciences. All right, in the next video I'm going to talk about distributed data collection.